This next question is from the AP test from a few years ago, and it's dealing with these differential equations. They first give a differential equation. A lot of times they'll ask you for you to complete a slope field based on that differential equation. It's a little more complicated than some of the ones that we've done so far. So let's break it down by looking at the different y values that we have here. If we have y equals 1, y equals 0, and y equals -1, just plugging that into the y part here, the top part, this would give me just a 0 for the dy dx. So all of these are going to be 0. We don't even have to worry about the x part on those. Looking at 0, that would give me a -1 squared. So going across here where y is 0, we're always going to get a +1. And for y equals -1, that would give us -1 minus 1 squared, which will give us 4 for the y part. We also need to look at the x part up here. If we have x equals -1, x equals 0, and x equals 1, the cosine of each of these, if we look at -1, cosine of negative pi would be a -1, and so each one of these would be -1. Notice I don't have to worry about these zeros again. And if x is 0, the cosine of 0 would be 1. So we multiply by 1 here, multiply by 1 here. And if it's 1, we would have the cosine of pi, and the cosine of pi is -1. So we'd have -1, -1. So filling in our slope field here, we're going to have zeros going across here. We're going to have -1, +1, -1 going across this line. And then across the bottom, -4, 4, and -4. So just make it really steep. Negative, positive, negative. And there's our slope field. Now for the second question, B, they tell us that there's a horizontal line with the equation y equals c that satisfies this differential equation. Find the value of c. Now we could just look at the slope field and notice we kept getting zeros going across here. And so it's really tempting to just say y equals 1 and leave our solution at that, but that wouldn't really be justifying our solution. We're making assumption based on our slope field. So to be sure, we're looking for where our slope would be equal to 0. So we're looking for a horizontal line. Also remember that a horizontal line is going to have the equation y equals some number. So setting my dy dx equal to 0, that would mean that y minus 1 squared cosine of pi x, which is my equation, equal to 0. Since it's multiplication here, that means either the y minus 1 part is equal to 0 or the cosine of pi x part is equal to 0. Now the x part, that's going to give us a solution in terms of x. It's going to be a lot of different values, but we don't want something in terms of x, so we're looking for a horizontal line. So let's come back to this one. We'll get the solution. The only solution to this is y equals 1. So that's going to be the answer. So that will be a horizontal line that satisfies the conditions they're asked about, and we can confirm it by looking at our slope field. But we justify it by working this out algebraically. Okay, the third part of this one is a little more complicated. They ask for a particular solution. So we're going to have to solve the differential equation. So for this part, we're going to have to solve the separable differential equation. So we're going to move our y's over to this side, which will give us y minus 1 to the -2. And then on this side, cosine of pi x dx. And we could use a U-substitution on each of these parts, but we might recognize, since it's fairly simple here, since it's just pi x, the antiderivative of this cosine should be sine. Keep the inside the same, pi x. But in order for this to work, we would have to multiply by 1 over pi, which is the inside. So let's check that. The derivative of sine would be cosine pi x times the derivative of the inside, which is pi, which will cancel that out. So that's our antiderivative. Again, if you don't see that, you could use a U-substitution. We'll put a plus c over here. For this one, antiderivative, we will increase our exponent by 1, y minus 1. Notice that the derivative of the inside is 1, so we don't need to bring anything out. The derivative of this would just be, well, actually I am missing something since it's -1. So the derivative of this, since it's the -1, would be negative times negative, make it positive, and then subtract 1 from our exponent. The derivative of the inside is 1. So that's finished. That's our antiderivative. Now we haven't really found the particular solution yet because we need to have this solved for y. Now we want to use this as our initial condition so we can plug in 1 and 0 for this. So when x is 1, then y is going to be 0. Now the sine of pi is equal to 0, so that would just leave us with c on this side. Negative 1 will give us a positive 1. So our constant is c. So we can take that and plug it back in to our earlier equation. Now let's rewrite this as a negative 1 over y minus 1 equal to sine of pi x over pi plus our constant plus 1. And we're going to have to solve this for y. So to keep this going, we're going to need to somehow flip this over. So let's combine this side over here. Let's treat this as pi over pi, which will give us sine of pi x over pi plus pi here. So now we can flip both sides. We can multiply by the negative there. And we can also add this 1 over to the other side. Okay, now we have y by itself. Even if we could simplify this side more, we can just call it quits right now and say y is equal to, this is our solution to our separable differential equation.